In order to solve any problem that involves Newton's second law, you're going to need to find the net force, net total force acting on an object. Let's look at a couple of examples and teach you how to sum up or add up all the forces acting on a particular object. The first object I want to discuss would be, say, a car driving down the road and accelerating. The forces acting on that car. The car's on a road, so there's a gravitational force and a normal force. There'd also be some sort of a force that's causing the car to accelerate, some sort of a pushing force. Because I don't have a better name for it, I'm going to call it an applied force. I like to put a separate note next to my free body diagrams of the direction of motion if known. This car's also got a couple of resisting forces acting on it. The first being friction, and the second one being a drag or air resistance. So, to sum up the forces acting on this car in this example, I want to do one thing to begin. I want to separate the forces into their x and y components. The reason being that vertical forces have zero effect on horizontal forces and vice versa. They act completely independently. It has to do with the fact that they're perpendicular to each other. So I'm going to create two columns here, the sum of all the horizontal forces. I'll treat this way as positive x. So I'll say that the total forces in the x direction are the applied force minus the drag force minus the friction force. Here I'm using the sigma, Greek letter sigma. It stands for sum. Now let's do the vertical direction. Again, declaring that this way is going to be positive. This is what it would look like to sum up all the forces acting on that car. I've separated horizontal and vertical in order to analyze them separately. Now Newton's second law, remember, says net force equals mass times acceleration. So here, this is a net force. It's a net in the horizontal direction. And because acceleration is a vector, it has direction. Previously I said I'm talking about the x, so I'll also say x here, this being a subscript. So here I could make this substitution. And here I can do a similar move. Now in this case, I've got a car resting on the road. Vertically speaking, it's at rest vertically. So the sum of the forces has to be zero vertically. But again, though, I'll make this substitution. Where I note that the acceleration in the y direction is zero.